Girl said I was taking short.
No, I got a wedding tomorrow. It's Pego's wedding, yes.
It's Pego's. It's his third wedding. When's the third wedding?
Pego wedding.
Because that's a genius move. It just came out last night. Whose water is this?
I was like,
It was here before I was here.
He went sick on his thing. He said yesterday in this class, I'm gonna go home early and play 2K.
Alright.
That is genius. I should, Mr. Lord, can I go to the office now?
Open up.
Okay.
Give the water bottle, you throw it away.
Hey,
He didn't hit
alright.
his last night. He's not that good. Like
Okay,
I stayed up.
let's go through the definition. We have a couple examples here. Pretty easy ones. We get to the examples. I got 4 that I picked out. They're fairly quick if you have your calculators with you. Alright, here we go. Alright. Okay, logarithms. Here we go. Let's do a definition. Definition of a logarithm. Okay, a logarithm, by definition, is the inverse function. This is the inverse function is the inverse function of the exponential form f of x equals 10 to the x. That's what a logarithm is the opposite of. It's the inverse of this thing. So what I mean by that is that a logarithm, when you write an actual log, like you write log of x, or log of 2, is equal to, like whatever that is. What you're trying to figure out is that it's 10 as a base if it's not written, to this power, which I'm trying to find out, equals this thing. It's literally the inverse of 10 to the x equals a number. Now, in my case, the number happens to be 2.
Can we switch that? That's a good right. Let's make it 100.
Make it 8,000.
No, it's just 20. We need to get used to this. It can be any single number that we want. But that's what a logarithm is. It is literally the inverse function of the exponential form 10 to the x. Now, we can change the base on a logarithm. We've done that in pre-calc. If you want to change a base on a logarithm where you don't want a 10, because on 10, you don't actually need to write it.
It's just log.
So yeah, you can just write log 2, type that in. If you want to change the base, here's how you can do it. You can put a new number. You can put a new number. So if you want to put a 5 here, the trick is if you want to change the base, you can drop this. So if I want to type in log to the 5th on a calculator, this 5 can drop to the bottom and become its own log like this. That can be log 2 over log of 5. This is called the change of base formula. By writing it something like this, I can go backwards and forwards between these. So I can start writing logarithms with different numbers other than 10. Because if I have a 10, I don't need to do anything. It's already a 10. But if I want to change the number to a different number like a 5, this is the trick. You can drop the log out the bottom and write it there. That's how you can do a change of base formula. It's pretty slick on the way that it works. Because what it's actually doing is it's making both logarithms 10s now. That's what it's doing. So you can make it any number you want. Okay, and I can go backwards and forward. All right. Hey, that's a logarithm. Now, a natural log.
You know what I'm saying? Look at everything that's really
Hey.
Hey, it wasn't me this time. Did you see that? I was quiet.
Okay. Natural log.
Are you just gonna change the little letter?
Yes.
I'm gonna rewrite.
Okay. A natural logarithm. Alright, a natural logarithm is f of x, and it's going to be e to the
You
x.
spelled logarithm different that time.
How?
Last time logarithm? Yeah, last time. There's no way.
Ooh! What?
No, you didn't. No, you didn't. I wrote it in and looked up and there wasn't
No,
a
you
there.
spelled it the same.
Let's go to the camera. There's it's a logarithm.
No way. There was no A.
Let's just look at the camera.
There was no A because I said, ew, I hate how
Because I wrote down an A and then I was like, oh, it's not logarithm, and then I had to erase it.
I think you did.
There was no A. There was no A.
But I spelled it right without even it
It's
being.
got an A.
Why?
No, you
Put
didn't
an
spell
A.
it like that.
Mr. Ward, check the footage.
Hey, leave the camera on. Alright,
Wait, so there
Okay.
is an A?
there's an A.
So I have to erase it again?
Logarithm.
Because that's how I wrote it.
I wrote it
Logarithm.
I wrote it.
Not
So wait, what's the definition? Will you
logarithm.
erase that whole thing? Is it inverse function? That's what that
It's
is.
the inverse function of the exponential e to the x. Now, natural log, instead of,
He's been 15. He lied to me.
they tend to do that.
Holler if you need help. That was what I was
Well, yeah.
We're gonna have safety words.
This is why it's like.
No, stop. Alright,
The same
Okay.
for logarithm.
hey, logarithm, natural log of, let's say 3. What this is it's the log of the natural number e, to the 3. So what this is just a shorthand of writing it if you're ever doing a logarithm with the natural number. That's what it is. So if you do a circle method, you know, where you want to make some e to the x, you want to make it 3. The idea is that it's going to be log base e of 3 equals the x, because the idea is that every time you do a logarithm, either natural log or log, it's giving you the power. It's giving you the exponent. That's why we use logarithms. It's what power can I put on this exponential that will make it the number that I need it to be. So like if I want to make e into a 3, I got to figure out what power that's going to be. Now the natural number e. This is something I don't know if I've talked about. This is the number I don't know if I've discussed. The natural number for e comes from the compound formula of this. So here it is. It's amount 1 plus r over n, n to the t. What this is, yeah, I'll just leave it. What this formula is, this is the compound formula for interest rate, right? And what they do is to make this into the natural number, they do this. In fact, I wonder if they have, I think they just have an N there in the book. They do, they just have an N. Alright, so what they do here is they'll change this to be this. So they'll make this N over R in the power. So they're gonna make that N to the R, and what they'll have to do here is they're gonna have to put an R on the outside as well.
Why?
Okay, because if you were to multiply these powers together, would you agree that the R's would cancel?
Probably.
Okay, if I were to multiply N over R times RT, the R's would cancel diagonally, and so it would be NT. Now, why they're doing that is because inside, they're gonna change this to be this. So that they're gonna do a reciprocal down, so they're gonna bring that R to the N down, and the next step is this. They're gonna substitute these out, where they're gonna make this, they're gonna make this an H, so like 1 over H, H, all to the NT, and the idea is that this part right here, I'm just gonna circle this part. Oops, that was an R. There's an R. Alright, what that is, that I put a box around. So what they're doing is they're doing conversion on the original formula, where this is the one that we used in pre-calc, but they changed the variable here, so they did a quick change, and this item, they replaced N over R with H, the mathematicians.
Wait,
So,
but I don't get it. What are we doing?
well, let me explain. You guys keep
Wait,
asking
I have a-
questions,
no,
and you guys
actual
are
question.
Well,
interrupting.
this is just too much.
I'm getting
Do you want me to write?
Hey, the door's over there.
Do you want me to write that blue in my notes, or is it not detrimental?
Yeah, do it.
So,
Jen, you wanna get punched?
I'm really annoyed. Shut up.
Hey, is that blue detrimental? Should I write it in my notes?
It's I'll punch you first.
Yeah.
She got some more difficult.
But I mean, is it gonna be on the test?
Right on camera.
so, it won't be used on the test. No.
Okay.
Now, what this is, this 1 plus 1 over H to the H, this part right here that I put the box around, that part, if H goes towards infinity, H, like, so you make that number bigger and bigger and bigger and bigger, and you put a power on it, that goes bigger and bigger and bigger and bigger, this number right here, this thing right here, if this were going to infinity, actually approaches the natural number e, which is about 2.71 blah, 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 blah. That's where the number, the natural number actually comes from. It's an interest rate problem where the power, the h, is the same as the number that's on the bottom of that fraction, and it's actually made from this compound interest formula. This is, what you're actually seeing here is the conversion for how you can make a normal compound interest formula into a continuously compounded problem using the e. And we had both formulas in pre-calc, if you can remember back. We did a bunch of problems with this in pre-calc, where I give you a rate, I give you how many times we compound, maybe compounded quarterly or monthly. We did problems where we compounded continuously, like a savings account, every second it's compounding. And that formula had this form. Yeah. This part right here, what you're actually seeing, actually, I better not circle the E.
Whoa.
Whoa.
There we go. The E that I'm circling there, that's the part that I have in the box. This thing is approaching E. It's approaching E, so E to the RT. And so this is the conversion that they did. That's where the actual, like, the natural number actually comes from. A lot of people don't get to see that. They just automatically know what E is, or they're just told that it's 2.7. It's a growth rate. This is the math you actually see where it's derived from. Now, what we're going to be using it for is solving a couple basic problems. So, first one. I like your, I'm going to start easy and we're going to kind of work our way to a more challenging one. 3 to the x equals 15. Now, what we're going to learn is how to do logarithms or natural logs to a problem so that you can actually solve for the missing variable. So like the exponent that's in the power. So the trick is, when you have an exponential equation, you can do what we call the circle method and write it back. So this is a lot of just review from pre-calc. So you're going to start, I'll use a different color here. We're going to start here with this 3. You're going to circle around until you equal the power. And what we'll do is we'll take the normal logarithm.
Normal?
So logarithm, not the natural log, but the
Log base 10.
log base 3 now. Log base 3, because this is the base number, of 15 equals the power.
Yes.
Okay. Now, there's a different way you can do this. If you don't like the circle way, like that method doesn't work for you. You can't remember what to put, where to put it. You're doing like, I don't remember the circle, I can't remember which number goes where. Here's what you can do. No,
Okay.
definitely not.
Why not?
It would take forever.
But it could work.
So now, what you can also do is you can do this. So 3 to the x equals 15. You can actually just take the log of both sides, because it's an equation, you can do the same thing to both sides. Just take the log
Oh, and it brings
of
the x
3x,
up.
log 15. So you can do it that way, because maybe this way it might be easier than trying to remember the circle. So you take the log of both sides, the power drops out front because that's a rule. That's actually a property of logarithms, that if you have a logarithm with a power, it drops out front. That's the power rule. And the last 2 steps here
Get
is
x
that,
on its own.
yeah, you get x on its own, so you divide the log 3 over. You divide the log 3 across. So log base 15, or log of 15 over log of 3. And then what you're allowed to do is, since that was what I showed you earlier today, you can, bless you, you can do a change of base, and you can bring the 3 back up and just make it the power. Instead of having base 10s, you can make it back to this. Because the item is that if you have a base that's other than 10, you could drop it on the bottom. And that's what I have there. So you could choose both ways. Now obviously one's way faster than the other.
Which one?
Obviously the circle.
Obviously the shorter one, duh.
But the idea is that you'll still get to the same answer. Now the problem is we have to learn how to type it. If you're going to type this in a calculator that will not allow you to change the base number, because some calculators can, you have to do that right there. You have to type in log 15 divided by log 3.
How do you know?
Okay.
The answer is 2.46.
2.46.
2.46497.
2.46314.
Okay.
You were so close.
Okay, 2.46. There we go.
Nice try.
All right. Are we good? Okay, there's the answer. Now what that number is, that's the power you'd have to put on a 3 to make it a 15. Because I think Drosty, I think it was you that said it, can we guess and check? It takes forever to get the right decimal. You could try, but it would take a long time, because here's how you can guess. So,
Should we guess and check on a test?
no,
Why not?
because I want 4 or 5 decimal places.
Yeah, you do.
What if
We could get pretty accurate for this.
I don't wanna argue with this, this is a stupid conversation, I don't do it. Alright, so, alright, 3 to the x. If you go 3 squared, that's 9. If you go 3 to the third, that's 27. So obviously the number had to be in between 3 squared and 3 to the third to get to this 15, this magical number 15. So the idea is that, yeah, 2.46 made sense. 15, it's closer to 9 than it is 27. So the idea is that that number would have to be, on the 1/2 of 2.5. But knowing what number it's going to be, that would take a lot of like practice, trial and error typing in numbers. If you can just learn how to take logarithms, you're going to be golden. Okay? All right. Now let's go to the next type of problem. So that was fine. That's fine and dandy. But when you get to an actual story problem, like the one that you had in your homework, the last assignment that I gave you, not this page. What is this page?
26.
26. It was the last one we did. I don't even remember what page it was. Page 17. The last assignment we did, there was one problem in particular. If you would have used a logarithm, it would have made the problem easier. Because what that
Why
problem,
didn't you teach us that before you gave us the assignment?
I already did. It's not even pre-cal. So
You don't know.
now, what that problem asked you for is it gave you a certain amount of people on a particular problem. So let's say there was like 10.5 million people. Okay, and it's growing. The population is growing at 3% growth.
Whoa, that's pretty big.
3% growth. And it wants to know what is the time, so this is the question, what is the time frame that's necessary that you'll double the amount of people? And it was a very similar question to this on the homework that we had. It was like one of the last questions. If you just used a logarithm, because it said like you're supposed to like graph and kind of plot the exponential and see kind of where it's going to go to figure out when it will hit double. The idea is that this is what you could have done. That if we know we're going at a 3% growth, this is it. Okay, so this is my growth problem. We're going at 3% growth, 100% plus 3%.
Right.
To an x, that's my time. My initial amount of people is 10.5, and I want to double that. So I want to be at what, 21?
Yes.
Which means
That's-
you just
that's
replace
double.
2 and 1 for doubling.
So yeah, so if we divide this over, you're gonna get 2 over 1 if I divide that over. I'm gonna get the 1.03 to the x. I'm gonna take the logarithm of both sides.
Yeah, we did.
Yeah, we already used log.
Log 1.03, you can drop the x out front and divide that over. And that will give you the time frame that it would take. And if it's growing at 3%, it'll take a while before it actually doubles. Okay, now just to get to that number here, I'm gonna type it in my calculator. Okay, so log of 2 divided by log 1.03, it was gonna take 23 years.
All right.
23.45 years.
Holy cow.
3% growth, it's not very fast, and we wanna get to double, so it's a little
Actually,
bit
that a savings account. Would that investment be worth it?
23 years, maybe.
Is that how long it takes anything to double, like at that rate?
At 3%, this amount,
Even if you had like a million, it still take 23.
well, if you wanna double, yeah, that's how long it would take.
So doubling no
3%.
matter what, at 3%.
At 3% would take that.
So just memorize the number.
Yeah, you can do
So
that.
like 1 through 100, you memorize all those numbers.
Alright, so that's doubling, alright. I'm only gonna do one more example, so you only get a third example today. We'll do a fourth on Monday. Okay, here it is, last example of today.
Told them 3 was sufficient. Oh my gosh, do you remember me saying that?
Okay,
Hey, why do you have a pin on?
Sufficient.
Oh, that's
Why do you have a pin on?
Bradley gave it to me today, this is, I was regret.
What's that for?
Mrs.
Did you
Jansen
read
was
Miles'
wearing Bryce Cox's button.
Who is
Thank
it?
you,
who is?
whoever said, you said that? Jansen.
That's awesome.
That's
Alright.
funny.
Okay, last problem of the day, last problem.
Oh, actually,
You wanna go start the set camera?
my dad.
Yes.
That was scary.
Alright. Okay, hey, last problem I want you to write down.
Last problem.
I can do a little better than that, but.
You're under pressure.
Sorry, I put you on.
Did you like how I tried? I was gonna try to teach you the lesson, like you started walking. I would've thought I could.
Okay.
You need to figure out what growth it is.
Backwards.
Okay, hey, there's two parts. I wanna figure out the growth that's involved here. And then the second thing I wanna do is figure out when will this thing hit 40 million people.
1963.
So, I wanna figure this out, okay? So to actually solve this, we're gonna do this problem slightly different than what we did earlier. Now, we're gonna assume, the book said on these problems, I think it said, find the formula for exponential growth, so it is exponential. What I would do is I would do this. Okay, so whatever your initial amount of people, so we're starting with 27, okay? At some point, we're growing at a certain rate in a certain time frame, and it will hit 31 million people. What was the amount of years between here?
62. Oh, 11.
11 years. That t is the 11 to that power. I'm using the p equals RT formula because we know it's exponential.
With a K coming.
You can, that's my growth. You can use R if you want to use R.
Why do you just put in
can't
random
say I'm
letters?
using the
Can you
PERT
just use me?
either.
Just use the
Sorry,
R.
when we did pre-calc, we used Ks. Sorry, I just went back to the pre-calc stuff.
Sorry.
All right,
I like that better.
but anyway, you can do this formula like what we did the other day,
Why is
where
it putting-
we divided and we were setting these up using the amount formula with a to the 0, a to the 4th. We did those a long time ago. But that requires you to do other.
Are we forced to use PERT?
What? On this, you can do it differently because
Log
we.
thing, like that.
Yeah, we did this method, we did on the last homework, where we did a of 0, because we didn't know the amount.
Right.
And we did, this is a to some number, and we always put like 4 and 15 in those
Can I use
numbers.
that?
You can use
Like
that,
this?
yeah. I just think doing it with the PERT formula on this one is faster, because on the other one you'd have to take a radical, like you have to take the power to the other side, take the radical, and use a fraction. This way, you just have to use logarithms and it'll get you to the same answer.
Okay.
So,
As long as you do the job, Mona.
alright,
I don't know if that's an answer.
no, hey, do you have a question about this?
I don't like
Okay, just wait. Alright. Okay, hey, dividing the 27 over, so we're taking 31 divided by 27, whatever that is, e to the 11r. Now, if we take the natural log of both sides, why I'm doing natural log is because I can drop the power and the e will go away. So if I do the natural log,
Colin, turn around.
stop,
They won't turn around.
They
stop, or
won't
you
hurt.
guys can move.
It's irritating us.
So, we're taking the natural log of both sides, we're gonna drop that power out front, we're gonna drop the 11r. 11r, natural log of e. We're gonna take the natural log of 31 over 27. And the last step is that the natural log of e will cancel out, because anytime you take the natural log of the natural number e, this just cancels out to make 1, because the power of 1 makes the natural log of e. And then the idea is that I'd have to divide the 11 over. So my final answer to find r, the rate that I'm growing at, because that's what they want to know in the first part of this problem, is I take the natural log of 31 over 27, whatever that is, and whatever that number is, I'm going to divide by 11. And that's my r. Now, I'm expecting your growth rate small, because we went from 27 to 31 in 11 years. It's not going very fast.
0.01.
0.01.
559, 122.
So say it again.
0.012559.
Yeah, that's fine. We'll just do 3.
Wait, whoa. Put a 6 after that so that it's more accurate. Thank you.
Okay. All right. 0.0126. Okay, that's my growth rate. So about 1% growth.
Holy cow.
Okay. We knew it was going to be small. Now, the second part of the question, now that we know growth, the second part of the question says, when will you hit 40 million people? Well, that one you're going to have to use the r and plug that number back in to figure out t. So this is the second and last part of that problem, is that you're going to type in the same problem. You're going to start with 27 million people. You're going to be growing at a rate of 0.0126, but I don't know the time frame. I just wanna know when will I hit 40 million. And same thing. Now, why we're doing this is because now that I know what my growth rate is for this data, I can immediately type it and go from there. This number, what's making sure that this is growing, that's a positive number. For the natural number e, if the power is positive, that means it's growing. If it was negative, it's going down. The difference between this one and that a to the 0 formula we did earlier is that when I did the 3% growth in the last problem, I used 1.03. That problem, we just had to make sure that we used a 1 in front. We don't need to do that here. This is going to show growth because it's natural numbers. But you still have to do the same rules. We still have to divide the 27 over, take the natural log of both sides, and then take the power. It's basically the exact same work we just did here, just different numbers, and we're solving for t, not r. Just to type this in.
31.2.
Say it again.
31.2.
Okay, so we solved for t, it eventually turned out to be 31.2. That's the amount of years it's going to take from the beginning. We started in 2004, and we had to go an extra 31.2 years.
2027.
No, not 27.
I thought you were being 4 years, I was so confused.
Okay, 2035.2, the 0.2 would be whatever the 0.2 is of a year, February, whatever it is. All right, questions?
Yeah. 31 minus 4.
Perfect. All right, homework today.
It should be longer than
The
that.
page 40.
It would be February 12th.
What?
It would be February 12th.